Hello students and welcome to the lecture. So students, as we know that in the previous lecture we had started the discussion over the light, right? And we had covered the part 1. In this lecture we are going to continue the topic of light and we will talk about the part 2. In the previous lecture we had talked about what do you mean by the light exactly, what is the review of light and some other phenomena that are related with the light. In this lecture, we will continue with some other more facts and figures that are related with the light and important to know for our better understanding of the topic. So here we will talk about the reflection of light, laws of reflection, reflection from plane surfaces, reflection from spherical mirror, sign convention, rules for image formation. So these 6 things we are going to cover, like starting with the reflection of light, laws of reflection, reflection from plane surfaces, reflection from a spherical mirror, sign convention, rules for image formation. Okay, but before this, there is a small disclaimer that is here. We are required to understand before we proceed further. The disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this tag and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the reflection of light. So, prior to start this, let me ask you one thing. In the previous lecture, when we were talking about the light, there was one thing that we had discussed. And what was that? If you went to a dark room, you will not see any object in that room, right? So you have to switch on the light. And then when you switch on the light, it's a time when you start seeing an object. Why? Because suppose this is a particular object, the light strikes on it and then it's reflected and now it is become visible to us. Here, what I'm going to ask you from the point of revision. What is that? Like, if this is the light ray and you are standing here, then only you can see that particular object. But could you see it from that side? Or could you see it from that side? No. Why? Because the light ray is only getting reflected from this side, so that object would be visible on that side only, not from this and that side. Okay? But normally when you enter in the room and you switch on the light, and if you are seeing there are the 4 chairs in the middle of the room. So if you take a round of the room, still you can say that there are the 4 chairs. Why? Because it is visible to you from that corner, this corner and every corner. Right? Why? Because on that time it is not the reflection of light, it is actually the scattering of light, which means that object is reflecting light in every sphere. So that's why it is actually visible from everywhere. So remember, the object could be visible and could be seen from every sphere just because of the scattering of light. If we consider the reflection of light or reflection of light, through some specific directions only we could see these objects. Okay, so remember this. So the return of light into the same medium after striking a surface is called the reflection. So here remember, reflection is return of the light into the same medium. For example, here you can say this is a solid medium. Here we are assuming an air or gaseous medium. So now the light came from this medium, gaseous medium, strike the surface of the solid and then again reflected back to the gaseous medium. Okay, it is known as the reflection. The light gets back to the same medium from where it was coming. Okay, there are usually two kinds of reflection that we consider: regular reflection and irregular reflection. Here you can say this is the regular reflection, this is an irregular reflection. So this is the further division of reflection. Okay, like if we talk about optics, what is optics? Optics is a branch of physics that studies the light, its phenomenon, and its other aspects, right? And optics further divided into two forms: geometrical optics and quantum optics, right? That is what we are known to. Okay, similarly, reflection is a phenomenon of light that is further divided into the two forms. One form is what we call regular reflection, another form is what we call irregular reflection. Okay, so now let's have a look over the first one, that is the regular reflection. A regular reflection occurs when a beam of light falls on a smooth and polished surface. Okay, like when the surface on which the light is falling or striking is actually smooth and polished. It is not uneven, but it is smoothly even surface. Example, plane mirror, etc. If a parallel beam of light incident on a plane mirror, the reflected beam of light is also parallel and is a fixed direction. For example, this is the plane mirror. Okay, so the surface of the plane mirror is smooth and polished surface. The smooth and polished surface. So here you can say the light is come from gaseous medium. Okay, and because this is a plane or smooth polished surface striking over here, then it is getting reflected. So now you can say the coming and reflecting both is in the parallel form. Parallel beam of light coming and parallel beam of light reflecting back. They both are in a parallel direction. Okay, fixed direction. Okay, they all are going in a fixed direction. If we consider this as a northwest, we strike on south going to the northeast direction. Okay, the direction is same for all the beams. This beam, this beam, this beam. So that's why this is what we call as an regular reflection. First thing clear? Irregular reflection take place when the reflecting surface is not smooth or polished. Example, wood, wall, paper, etc. So these are that surfaces which are not smooth and not polished. Okay. In this case, the different portions of the surface reflecting the incident line in different direction. For example, here you can say these are the light beams that coming, and here you can see the surface is not even, not smooth and not polished. It is zigzag or rough surface. The beam of light coming and striking over here. Then you can say the beam of light actually not going parallel to each other, not even going in the same direction, but they are intersecting each other and their direction is slightly different from each other. They both are going to the northeast direction. This is going to the northeast frontier direction. So here you can say the direction is not the same. Even they are not in parallel, they are intersecting with each other. If a parallel beam of light incident on a rough surface, the reflected light spreads over a wide area. Okay, why? Because the light is not parallel and even the direction is not the same. So if we go by the previous example, the object would only be visible in northeast direction. But here you can say some rays are also going beyond it. So the object would also be visible from the northeast frontier direction. Okay. Such a reflection is called diffused or irregular reflection. So diffused or irregular reflection, this is the same. Okay, please do not get confused in it. This is the same. It is the diffuse light which enables us to see the object around us. So remember, whatever object you are seeing around you easily, this is because the diffusion of light. Because the object is there, for example, parallel beam of light is coming to it like this, and now it's actually reflecting the light in every direction. Okay, so that's why it is actually making us unable to see the object from all the directions and easily to see the objects around us. If they all will be go in the same direction like this, then only from one particular direction the object would be visible and would not be visible from any change in the direction, because right now it's not receiving that particular diffusiveness that is requires. Okay, now what are some terms that are being related to reflection? Let's have a look on them. First term is the incident ray. So what do you mean by the incident ray? Let us understood this. So the light ray striking on a reflecting surface is called the incident ray. For example, this is the mirror. What is the work of mirror over here? It is a reflecting surface. Here you can say one incident ray is coming like this. This incident ray is coming, and here you can say it is actually striking the mirror or the reflecting surface. So that ray which is coming and striking the reflective surface, that ray is actually known as the incident ray. So incident ray is clear. Now point of incident, second term. The point at which the incident ray strikes the reflecting surface is called the point of incident. So if this is the incident ray and it is coming and striking the surface here at this point, so that point will be known as the point of incident. We could not take this point, we could not take this point, this, or any other point. Why? Because these points are not that points where the incident ray is coming and striking. The incident ray is coming and striking only this point, so only this point will be considered as the point of incidence. Third one, reflected ray. So the light ray obtained after reflection from the surface in the same medium in which the incident ray is traveling is called the reflecting ray. So let's understand this. This is the mirror, a reflecting surface. This is an incident ray coming towards it, striking at points of incidence, and thereafter you can say this red one. That is the new form of ray which was previously the incident ray, and it is again moving into the same direction from where, in the same medium from where the incident ray was coming. The incident ray was coming from air or vacuum. Reflected rays also going back to the air and vacuum. No difference. Okay. So reflected ray is actually the ray that is obtained after the striking ray hit the reflecting surface, and that ray is also directed towards the same medium from where the incident ray was coming. Normal. What do you mean by normal? A perpendicular drawn to the surface at the point of incident is called the normal. Here you can say normal. So this is the point of incident. From here we will draw a straight line on upside. And this straight line is what we call as the normal. Okay, it is the perpendicular drawn to the surface at the point of incident. Got it? Now, another point that is related with this is the angle of incidence. So what is the angle of incidence? Let's understand. The angle which the incident ray makes with the normal at the point of incident is called the angle of incidence. For example, here you can see this is actually the reflecting surface. Okay, here from the incident ray is coming and it is striking there. This point will be known as the incident point, from where the point to where the incident ray come and strikes. And from here we will draw a perpendicular, and that perpendicular will be named as the normal. That perpendicular will be named as normal. So here you can see with normal, however, the normal is having the 90-degree angle with the reference to the reflecting surface. But the incident ray is coming in this way. So the incident ray is making that particular angle with reference to the normal. So this angle that the incident ray is making with the reference to the normal is actually known as the angle of incidence. So the angle which the incident ray makes with the normal at the point of incident is what we call as the angle of incidence. Okay, it is noted by letter I. Here you can say I. Second one is angle of reflection. The angle which the reflected ray makes with the normal at the point of incident is called the angle of reflection. For example, this is what the incident ray is coming from the air or from the vacuum. Here it is striking at the point of incident. From here, this ray will be reflected back to the same medium from where it was coming, from the form of incident ray. So here you can say the normal is actually the 90-degree angle. Okay, but here this is the angle the reflected ray is making with the normal. So that angle the reflected ray will make, that is known as the angle of reflection. So the angle which the reflected ray makes with the normal at the point of incident is called the angle of reflection. So remember, this is, okay, let me make it again. This is the angle of reflection. This is the angle of incidence. Okay. The angle of reflection is denoted by letter R. After this, the real image. The image which could be obtained on a screen is called a real image. It is found where the light rays after reflection actually intersect. So remember, if the incident ray, suppose two incident ray came and they two reflected back. If they go parallel, there will be no image formation. But if they go parallel, after some time they intersect with each other, so here the image formation will be there, because it is formed when the light rays after being reflected or refracted got intersect. So until or unless the rays that got reflected and refracted intersect with each other, the real image could not be formed. Thereafter, virtual image. this one. The image which cannot be obtained on a screen is called a virtual image. So the image that is actually not obtained or existed on the screen, that is what we call as a virtual image. What is the distinction between a real and the virtual image? How you could distinguish between them? So this is the distinction between a real and the virtual image. For real image, for virtual image. A real image is formed due to actual intersection of the reflected rays. So when the reflected rays, for example, this is the reflecting surface. Reflected rays comes and strikes and goes parallel. So until or unless they go parallel, no image could be formed. But if they intersect with each other, then the image will be formed. So when the intersection of reflected rays happen, then the real image form. A virtual image is formed when the reflected rays meet if they are produced backward, which means that, for example, this is the plane mirror. Okay, so if you see, these rays are going parallel and these rays are not going to intersect each other. But if we draw a suspension lines from here, then we could say that these lines will intersect there. So here you can say the reflected rays are intersecting in the backward direction. So whenever this kind of situation happens, then it is known as the virtual image. A real image could be obtained on a screen. A real image could be obtained on a screen. A virtual image couldn't be obtained on a screen. A real image is inverted with respect to the object. Example, the image of a distant object formed by a concave mirror. So this is an object, it was in the upward direction. This is the real image. It is inverted in the downward direction. So the real image will always form in the opposite direction in reference to the object. A virtual image erect with respect to the object, which means if the object is in the upward direction, the image will also in the same direction. The image of an object formed a plane mirror or by a convex mirror. So remember, real image is always in the opposite direction. Here you can see it. And this virtual image always in the same direction or the erected the same directions. Now let's consider the laws of reflection. What are the laws of reflections? Let's look over here. So the reflection at a surface obeys the following two laws, which are called the laws of reflection. The angle of incident I is equal to the angle of reflection R. Therefore, angle AON, this one, angle AON will equals to the angle BON. So this is the incident angle, this is the reflected angle. Okay, so remember, angle of incidence and angle of reflection both will be same. Angle AON and angle BON, or angle I or angle R, they both are same. The incident ray, the reflected ray and the normal at the point of incident lie in the same plane. The incident ray, the reflected ray and the normal, they both are in the same plane. It means that plane. It is not like incident ray is in that plane, normal ray is in that plane, and reflected ray is some other plane. No, they all are obtaining from the same plane. Okay. In figure, AO, the incident ray, ON, the normal, and OB, reflected ray, they all are on the same plane, in one plane only. Therefore, the plane of paper. For a ray incident normally on a surface, angle of incident I equals to 0 degree. Therefore, the angle of reflection R equals to 0. Thus, a ray of light AO incident normally on a surface is reflected along the same path OA as shown in a figure. Now, reflection from plane surfaces. Let's have a look on them. So the image is always erect, virtual, and same size as the object. It is at the same distance behind the mirror as the object is in front of it. For example, this is the mirror. This is the mirror. Here we have placed an object. And if the image is formed beyond, so now you can say the image will be at the same distance. This is the mirror. Okay, it would be at the same distance from the mirror as the distance of the object. Okay, so it is at the same distance behind the mirror as the object is in front of it. If an object moves towards or away from a plane mirror at speed v, the image will also approach or recede at same speed v. Therefore, the speed of image related to object will be v minus into minus v equals to 2v. Similarly, if the mirror is moved towards or away from the object with speed v, the image will move towards or away from the object with the speed of 2v. So remember this thing also. Okay, now deviation presents by delta, okay, is defined as the angle between the directions of incident ray and emergent ray. So deviation is actually the definition of the angle between directions of incident ray and emergent ray. Okay, so if light is incident at an angle of incidence I, so if light is incident at angle of, then we can say delta equals to 180 minus bracket angle of incidence plus angle of reflection bracket close equals to 180 minus 2i. If I is 30 degree, then delta equals to bracket 180 minus 2 into 30 bracket close equals to 120 degree. And for normal incidence, angle of incidence equals to 0 and delta equals to 180 degree. If keeping the incident ray fixed, the mirror is rotated by an angle theta about an axis in the plane of mirror. The reflected ray is rotated through an angle 2 theta. Thus is illustrated in the figure. Here you can see. This fact is used in many optical instruments such as periscope, sextant, optical liner, etc. The image formed by a plane mirror suffers lateral inversion also. Therefore, in the image formed by a plane mirror, left is turned into right and vice versa with respect to object as shown in the figure. So if you see, this is an object and this is the mirror. So here you can say these things are getting interchanged. First, the direction of R. The R was in this direction. Now it is in this direction. Here first is R. Here first is L. Here last is L. Here last is R. So actually we could say that is getting inverted or reversible. However, the mirror does not turn up and down. The reason for this is that the mirror actually reverses forward and back in 3 dimensions and not left into right. Therefore, only Z direction is reversed, resulting in the change of left into right or vice versa. So here you can say the Y and X fixed, only the Z is actually changing. That's why left hand appears as a right hand and similarly the right hand appears in the left hand. Actually, a plane mirror changes right-handed coordinate system or screw to left-handed. As every part of a mirror forms a complete image of an extended object, and due to the superposition of images, brightness will depend on its light reflecting area. A large mirror gives more bright image than a small one. This in turn also implies that if a portion of a mirror is obstructed, complete image will be formed out of reduced brightness. To see his full image in a plane mirror, or a person requires a mirror of at least half of his length. To see a complete wall behind himself, a person requires a mirror of at least 1/3 of height of wall, and he must be in the middle of wall and mirror. If two plane mirrors are inclined to each other, having the angle of 90° or perpendicular angle, the emergent ray is always anti-parallel to the incident ray if it suffers one reflection from each, as shown in a figure. This one you can say. This is the incident ray, this is the reflected ray, and here you can say 90° is actually inclination. Whatever be the angle of incidence, the same is found to hold good for the three-plane mirror forming the corner of a cube if the incident light suffers one reflection from each other. If there are two plane mirrors inclined to each other at an angle theta, the number of images of a point object formed are determined as follows. If 360 by theta equals to is an even integer, say m, number of images formed, then n equals to m minus 1 for all positions of object. If 360 by theta is odd integer, say m, number of images formed, then n equals to m if the object is not on the bisector mirrors. N equals to m minus 1 if the object is on the bisector of mirrors. Now, if 360 by theta is a fraction, the number of images formed will be equal to its integral part. All this is given below in a tabular form. Like here you can see. At 0°, infinite, infinite, infinite. 30°, 12, 11, 11. 45°, 8, 7, 7. Number of images formed symmetrically if object is placed symmetrically. Here you can say 60, 6, 5, 5, 72, 5, 5, 4, 75, 4.8, 4 and 4, 90, 4, 3 and 3, 112.5, 3.2, 3 and 3, 120, 3, 3 and 2. So you could check it by yourself. There is nothing to explain over here. It is just an ideological form. The beautiful patterns observed in the toy kaleidoscopes are in accordance with this principle. This is the kaleidoscope. In your childhood, you must have prepared it. If an object is placed between two parallel mirrors, then theta equals to 0°, the number of images formed will be 360 by theta infinite, but of decreasing intensity in accordance with I is directly proportional to 1 by r square. Two mirrors inclined to each other at different angles may provide same number of images. Example, for any value of theta between 90° and 120°, the number of maximum images formed is 3. This in turn implies that if theta is given n is unique, but if n is given theta is not unique. Now what are the uses of plane mirror? Let's have a look on them. As a looking glass, here this is the mirror most of us use in the house room. In the optician room, to increase the effective light of the room by keeping a plane mirror on the front wall and the signboard on the opposite wall behind the patient. For the patient, the signboard is at double the length of the room. In a periscope, two plane mirrors each inclined at 45° with the vertical and facing each other. In a kaleidoscope, three plane mirrors inclined with each other at 60° are used. In the solar heating devices also, we use them. Now, let's have a talk over the reflection from the spherical mirrors. For spherical mirrors, a spherical mirror is made by severing a piece of glass which is the part of a hollow sphere. Spherical mirrors are of two types, the concave mirror and convex mirror. For concave mirror, a concave mirror is made by silvering the outer or bulging surface of the hollow sphere such that the reflection takes place from the concave surfaces as shown in the figure. Here you can see. This is the concave mirror. Convex mirror is made by silvering the inner surface of the hollow surface such that the reflection takes from the outer surface as shown in the figure. This is the convex mirror. Brief introduction of terms related to the spherical mirror. Center of curvature. The center of curvature of a mirror is the center of sphere of which the mirror is a part. Radius of curvature. The radius of the sphere of which the spherical mirror is part is called the radius of curvature of the mirror. Here you can say this is the center of curvature. This is the radius of curvature here. Radius of curvature. For spherical mirrors, we just cut down a sphere into two parts, so that's why we consider these things. Pole. The geometric center of the spherical surface of the mirror is called the pole of the mirror. Here you can say geometrical center. Aperture. The part of the mirror which is exposed to the incident light is called the aperture of the mirror. This is called aperture of mirror. In the concave case, in the convex, that is called the aperture of mirror. Thus, it is the surface of the mirror from which the reflection occurs. Principal axis. It is the straight line joining the pole of the mirror to its center of curvature. This is the pole, center of curvature. Here you can say this is the straight line. So this straight line is what we call as the principal of axis or principal axis basically. Focus. The focus of a concave mirror is a point on the principal axis through which the light rays incident parallel to the principal axis pass after reflection from the mirror. The rays come, then reflected, and here you can say passing from here. So it is known as the focus. The focus of a convex mirror is a point on the principal axis at which the light ray incident parallel to the principal axis appear to meet after reflection from the mirror. Focal length. The distance of focus from the pole of the mirror is called the focal length of the mirror. The focal length of a spherical mirror is equal to half of its radius of curvature. The reflection of light from a spherical mirror also follows the laws of reflection. Therefore, the angle of incident always equals to the angle of reflection. The incident ray, reflected ray, and the normal lie in the same plane. Sign convention. At present, following sign conventions is adopted. Whenever and wherever possible, the ray of light is taken to travel from left to right. The distances of a principal axis are taken to be positive while below it negative. A long principal axis distance measured from the pole and in direction of light are taken to be positive while opposite to it negative. This is why a convention U or V is taken to be negative in front of the mirror and positive if behind it. These are based on the laws of reflection. Therefore, angle I equals to angle R. Usually, following rules are followed. A ray parallel to the principal axis after reflection from the mirror passes or appears to pass through its focus. First law. A ray passing through or directed towards focus after reflection from the mirror becomes parallel to the principal axis. So these two laws will follow for the image formation. Third is a ray that is being passed through or directed towards the center of curvature after reflection from the mirror retraces its path. As for it, angle I equals to 0 and so angle R also 0 because angle I equals to angle R. So this is the third point. So here we have finished this particular part also. It is highly recommendable and advisable to all of you. Kindly revise the facts and figures. Why? Because in light, if you consider the part 1 and part 2, then you can say we have discussed so many facts and figures. And if you are not revising them on time, that will be difficult for you to do it in the end. With this note, let's end this lecture and thank you.